Hello, I'm Stephan Richter from Hasso Plattner Institute, and I present you Bootstrapper, work I've done with my advisors, Christian Holz and Patrick Bawish. So a possible scenario for Bootstrapper is when multiple students are interacting with the tabletop system, and Bootstrapper then allows the teacher to monitor the progress of every student and to support them best at the end. How we're doing this here is we mount one or multiple Kinects around the edges of the table, and then we observe the shoes with the Kinect, and by using these textures, these shoe textures, we can then identify the users. So let me walk you through the system here. I'm going up to the table, then the system recognizes my shoes, and as a confirmation, it displays my badge. And now everything I'm doing with the system gets logged into my badge, and every math achievement basically. At the end of the day, my teacher can check out the progress I have made and the progress of my fellow students. So as you can see, a friend of mine already got it, and I need some help with math. So when multiple users interact with the system, it's not sufficient to just identify the users, but we also need to trace the individual touches back to the users. So here's how we're doing this. We get an DI shadow from the DI system, so basically Microsoft Surface, and then we can trace the arm reflection back to the user, and we get the direction. So when a new user comes up to the system, a placeholder badge shows up, since the shoes are not in the database yet, and the user is asked to enter her name or upload a photo. The same thing happens when I come in with new shoes. So a placeholder badge shows up, and then I can basically link the shoes to my profile. So here's Bootstrapper in contrast to the related work. We have identified three major parts of related work regarding the identification of tabletop users. So the first thing is by possession of tokens like RFID badge, or by wearing wristbands or IR rings. So the second part is basically diamond touch, where users were identified by where they are sitting, so basically by which chair they sit in. And the last part is biometrics, where users were identified by fingerprints or the shape of their hands. So Bootstrapper is really different to this, since it requires no key card or ring to identify people, and unlike Diamond Touch, for example, it allows the users to move around freely, since the feet are aligned to the ground. And unlike biometric stuff, the hands are basically kept free to interact with the system. So we think this could work, for example, in a kindergarten environment where the users have no key card, or maybe lose them and they are running around frequently. So here is why it works. Basically, we have two things here. The first thing is that unlike hands, shoes have much more salient features. And the second thing is, since the shoes are aligned to the ground, we have a much simpler recognition problem, and it's basically a 2D problem. So here you can see also the shoes we recorded. There are some limitations though, since when people wear the same or they dress the same, the system perceives them as the same, and so they get the same profile assigned. So this is why we would not use Bootstrapper for authentication or log into a bank account, but for example, it suits well for logging. So here's how it works in detail. We have two steps. The first thing is the identification of the users. So we get an RGB image from the camera, we get a depth image from the camera, then we subtract the background, we get a mask, and with the mask we can extract the shoes. From the shoes we can extract a HSV histogram and some surf features, and then basically match the shoes against the database. Second part of the algorithms is the touch association. So here a user is standing in front of the table, and this is what the system sees. Basically, the hand sliding towards the edge. We binarize this image and get the shape of the hand, And when we extrapolate this, we get the direction of the elbow of the user, and from the shape of the hand, we can also determine the handedness. So this was a right-handed user, and now we can apply an offset based on the right hand to get the direction to the body. So we did 2 evaluation studies to show how well it works. The first thing was about recognizing the shoes, where we asked people to interact with the system, and then a camera recorded their shoes, and we got 18 different users with different pairs of shoes, basically. And in the end, we're getting a recognition rate of roughly 96%. So here's the confusion matrix of this, and it turns out, well, black shoes were confused with black shoes, but overall, it's okay. And the second evaluation was about associating touches with the user, where we asked people to point at different targets on the screen, and they were standing at different positions. We got 13 participants for this. And here is the distribution of the offset I talked earlier. This is the offset between the direction to the elbow and the direction of the body, so where the user really stood in the experiment. And we can see that the average is at about 20 degrees, and when we apply the offset of 20 degrees, we get a spread of plus minus 20 degrees. And if this is an error in associating a touch to a user, depends on how many users are standing around the table. So, for example, when only one user is at the table, it's totally no problem. Even if we have 2 users, we have correct association of 99.7%, and even if we have 5 users, which is a lot for a small table like Microsoft Surface, we get a recognition rate of, or a touch association rate of 92%. So in the end, let's come to the conclusions. I hope I've convinced you that we can use Bootstrapper, for example, for applications like logging tabletop activity, and although I haven't shown this today, we could also use it to basically do everything that has been done after identifying tabletop uses, like, for example, personalized interaction and so on. And on a more technical level, our contribution is the following. Traditionally, we have thought when we want to identify touches, we have to identify the finger of the person who's touching. But with Bootstrapper, we challenge this, since we take the shoes for identifying the person. And we think that in the future, by using sensors like Kinect, we can take basically the whole human skeleton and everything that is connected to authenticate or to identify every part of the body. So, for example, we can take the shoe to identify the hand, or vice versa. So, I'm coming from Hasso Plattner Institute, and we have one open PhD position or postdoc position, and I'm happy to take questions.